You've heard of REST APIs. You've probably used one without knowing it. Every time you open a weather app, book a flight, or log into anything, an API is doing the work. You'll actually understand how in this episode. An API is just a contract between two computers. One computer is called a client, which asks for something, and the other, the server, has the data and sends it back. Your phone is almost always the client, Netflix, Google, your bank, those are the servers. Neither side needs to know how the other works internally. REST is just a style of communication that they agreed on. REST isn't a tool you install or a language you write. It's a set of rules, like traffic laws. Different apps built by different companies in different programming languages can all talk to each other because they agreed to follow the same rules. Roy Fielding wrote these rules in his PhD dissertation in 2000, and that paper quietly became the blueprint of how the entire modern web communicates. REST has 6 constraints. Client-server means the UI and data logic are kept separate. Your app doesn't care how the server stores data and vice versa. Stateless is a big one. The server remembers nothing between requests. Every single call has to carry something that the server needs to respond. No memory, no sessions sitting on the server side. Cacheable means the common responses can be stored and reused. Layered system means there can be middlemen, load balancers, cache, gateways between the client and the server, and neither end needs to care. So you can have database, cache, load balancers between your client, which is your browser, and your server, which is your app server. REST is built on HTTP methods, the same protocol your browser uses. And HTTP gives you verbs. Get means give me this. Post means here save this new thing. Put replaces something entirely, and patch changes just one part of it. Delete removes it, and the URL tells the server what you're acting on. The method tells it what to do. Together, they basically cover everything any app ever needs to do with data. Now let's look at this request. Here's what it actually looks like. The first line has a method and URL. The headers carry metadata, who you are, what format you want, and auth tokens. The server reads all of this, processes it, and sends back a response. It's almost always a JSON in 2026. JSON is the structured text that both humans and machines can read easily. This is why REST won. It's predictable, readable, and works in any programming language. Every response from a server includes a 3-digit status code. Think of it as the server's reaction. A status code starting with 2 means that it works. One starting with 3 means that the resource moved. Go look over there. And something starting with 4 means you, the client, did something wrong. Usually means that the server itself has failed or the backend API has failed. A good API uses these correctly. A bad one returns 200 even when something went wrong, and this hides error inside the response body that often drives developers insane. A good REST API design is mostly about URLs. Use nouns, not verbs. The HTTP method is already the verb. You don't need to repeat it in the URL. Think of your URLs like a filing cabinet. /users is the drawer, /users/5 is a specific folder. /users/5/posts is what's inside that folder. Predictable, hierarchical, and a developer can guess the next endpoint even before checking the documents. The bad examples on screen are real patterns shipping to production right now. Because REST is stateless, the server keeps 0 memory between requests. You have to prove who you are every single time. The most common way today is JWT. It is what we call a JavaScript Web Token. It is a signed token the server issues at logins. The client attaches it to every request, like showing your ID at a door, and API keys are simpler, like a password for server-to-server communication. OAuth is what powers the login with Google that you see on different clients, and you're basically trusting Google to vouch for your identity so that the other app never has to see your password. So this is how it actually works. A request is when a client sends a token to the server verifies that token to see if the client is genuinely who they say that they are, and sends back the data to the client. If the client sends a token that the server does not authorize, then the server simply terminates that request and does not send back the data. Now, REST isn't the only way to build APIs in 2026, but it's still largely the default. GraphQL lets the client say exactly what fields it wants. It's great for complex front ends that need fine control over data. It adds overhead for simple use cases. gRPC uses binary encoding instead of text, so it's extremely fast. The go-to for communication between internal microservices, but it's not that easy for humans to read, so developers don't really find it friendly. REST sits in the middle. It's readable, well understood, battle tested across 2 decades. If you're building a public API and you don't have a specific reason to pick something else, REST is still your answer. Quick ones. Don't use GET requests to mutate data. GET can be cached and prefetched by browsers, which means your delete might never actually run. Always return the correct status codes. Don't make developers parse your error messages. Version your API from day one or you break your client the moment you make a change. Add rate limiting before you go live, and never ever return password fields in response. These are not hypotheticals, they are in production code bases right now all across the world, and it's usually an easy way for a hacker to get access to your system. That's Rust, a 25-year-old idea still running the backbone of modern internet, because it's simple, predictable, and scales. You understand the client-server model, the constraints, the verbs, the status codes, and the auth patterns. Now go build something.